All right, so we've gone over the principal quantum number n, which tells us the overall size and energy of the orbital. We've gone over the angular quantum number, which tells us the shape of the orbital. Next up is the magnetic quantum number, which gets the symbol of m sub L. So it's a lowercase m with a subscript L. And what this tells us is the orientation of an orbital. And m sub L can have values from negative L to 0 all the way to positive L, and it must be integers. So let's take a look at that. So if L is equal to 0, right, then m sub L can only be equal to 0. If L is equal to 1, then m sub L can go from -1 to 0 to 1. If L equals 2, then m sub L can go from -2 to +2. So -2, -1, 0, 1, and 2. If L is equal to 3, m sub L can be equal from -3, -2, -1, 0, 1, 2, or 3. And then don't forget about the letter designations of these L's. If L is 0, we say we have an s orbital. If L is equal to 1, we say we have a p orbital. If L is equal to 2, we say we have a d orbital. And if L is equal to 3, we have an f orbital. And these are all the different orientations you can have these orbitals at. So kind of a good picture here is one of, the S only has one orbital. So if you're thinking about the kind of shape over here, there's only just one way to organize it. And then if you're thinking about the shapes here, you can have multiple different shapes. Or not shapes, but orientations. So we can have the dumbbell going along this upper axis, the dumbbell going along this horizontal axis, or the dumbbell going along this kind of in and out axis. So if you think about the number of orientations that you're going to have here, you're only going to have one orbital. Here you're going to have 3 different p orbitals. So you only ever have one s orbital. You only have 3 p orbitals. When d orbitals, we have 5 of them. And then f orbitals, we have 7 of them. Let's see. And so when you kind of combine all of these numbers, you get something that kind of looks like this, that tells you the organization of the energy levels of orbitals within an atom. So down here, right, you have n equals 1, and then you've got an s orbital, so that means L is equal to 0. Right here, you've got n equals 2, and same thing here. But here you've got an s orbital, so L equals 0. While over here, you've got a p orbital, L equals 1. And you can tell you only have one s orbital because m sub L can only be 0. Right? When we move on to the p orbitals, m sub L can be -1, 0, or 1. And so that's what these 3 p orbitals represent. They represent the orbitals in different orientations, right? So one's -1, one's 0, one's 1. Right? And this is m sub L. And so you can continue on and continue forth, right? You have 3s, 3p, 3d, 4s, 4p. So again, the kind of takeaway here is that m sub L tells you how many of each orbital you have. So s, there's only ever 1. P, there's always 3 p orbitals. D, there's always 5 d orbitals. And f, there's always 7 f orbitals. And so last quantum number is the spin quantum number. And this tells us the spin of an electron. Put that in quotes. It's not quite exactly spin when you kind of think about it, but don't worry about it too much. And so it's either, can be one of 2 values, either +1/2 or -1/2. And when it's +1/2, we say that it's spin up. And we draw this kind of half hook arrow pointing up. And when it's -1/2, we say it's spin down. And so we fill it going, we draw this arrow going down. And so the important thing to note about this is that no two electrons can have the same set of quantum numbers. So if you think about this 1s orbital, both of these, or all the electrons here have n equals 1. They both have L equals 0. They both have M sub L equaling 0 as well. And then if you think about it, they can't have all the same quantum numbers, so then you have M sub S. One of them is +1/2, one of them is -1/2. And so they don't have the same four quantum numbers. So what we say is that one is spin up and one is spin down. And so what this does is it limits 2 electrons per orbital. Right, so we can put 2 here, and then we can put 2 in each one of these, right? So 2 electrons per orbital, one spin up, one spin down. So this is pretty it's pretty high level stuff, but you really want to get a good grasp on this. We're going to be going over more of this kind of later on, but you just kind of want to get an idea of what all these values can or cannot be.